Let's take a look now at the remainder and factor theorems. The remainder theorem, and again, keep in mind our goal here, because we just learned how to divide, and you're probably like, why did we divide? But we divided because we want to be able to solve polynomials, and again, the remainder and factor theorems will help us to solve polynomials as well. The remainder theorem tells us that if we have a polynomial divided by x minus c, then the remainder is f of c. So essentially what I'm saying is, instead of me having to take 5x to the 7th minus 3x to the 5th plus 2x squared minus 1 and divide it by x minus 1 and do all of the work and then find out at the end there's some remainder, and I think, well, crap, I really wanted something without a remainder. Instead, I can do the check beforehand, which is a lot easier, especially if I use a calculator. I can take f of 1 and say 5 times 1 to the 7th minus 3 times 1 to the 5th plus 2 times 1 squared minus 1. 5 times 1 to the 7th is 5. 3 times 1 to the 5th is 3. Keep the minus. 2 times 1 squared is 2. So I get 5 minus 3, which is 2, plus 2 is 4, minus 1 is 3. So I know already that if I did this, when I got to the end, my remainder would be 3 divided by x minus 1. And what I really want is to be able to have a remainder of 0. So this saved me from doing all of this long division and then determining that, nope, that didn't work, and now I have to try another factor. It told me right away, don't use 3 as a factor. Or I'm sorry, don't use 1 as a factor. So that's what we did. So that's what I did here is I used the remainder theorem, which says plug in the 1, evaluate, see what you get as a remainder. The factor theorem tells us, again, that if f of c is 0, which means if the remainder is 0, then x minus c is a factor. So let's take a look, and this one is going to suck a little bit because I gave you a hard one. I want to show that radical 5 is a factor of this polynomial, which means this would be x minus radical 5 would be a factor of this polynomial. Now, how can I show that? Well, all I have to do is take f of radical 5. So, radical 5 to the 3rd minus 4 times radical 5 squared minus 5 times radical 5 plus 20. And this one's going to be tough a little bit because you might not have used radicals in a while, so you might have forgotten some of the fun things we can do. If I have radical 5 to the 3rd, remember that's radical 5 times radical 5 times radical 5. Well, let's say I took radical 5 times radical 5, what would I get? I would get radical 25, which is 5. Well, this guy, unfortunately, is left solo. So that first term is going to turn into 5 radical 5. Then I have minus 4 times radical 5 squared. Well, as we just talked about over here, if I take radical 5 squared, which is what I did right here, I get radical 5 times radical 5, or radical 25, which is just 5. So this term turns into 5. Sorry, no it doesn't. This term turns into 5, but it's minus 4 times 5, so that's minus 20, because I've got minus 4 times positive 5. Then I've got minus 5 radical 5 and plus 20. And as we can see, I've got a 5 radical 5 and a minus 5 radical 5, and those are going to cancel. And then I've got a minus 20 and a plus 20, and those are going to cancel. So what am I left with? Nothing. So what I've done is I've used the factor theorem to show that because my remainder is 0, that I could use long division or synthetic division to divide this by this and see what I have left over. And it wouldn't be a remainder. So again, let's look at another practice together. This one says use the factor theorem to determine if x plus 4 is a factor of the polynomial given. So first thing I'm going to do is say x plus 4 equals 0 means I'm going to plug in negative 4. So I'm going to take f of negative 4, which means 6 times negative 4 to the third plus 11 times negative 4 squared minus 60 times negative 4 minus 32. Time to get your calculators out. My first term is negative 384 plus 11 times negative 4 squared is 176. Negative 60 times negative 4 is positive 240 minus 32. Now I'm going to take negative 384 plus 176 plus 240 minus 32, and I end up with 0. Because I have a remainder of 0, then x plus 4 is a factor. The 0 is negative 4. The factor is x plus 4. Now, again, why would I do that? Because now I know x plus 4 is a factor. I would use either synthetic division or long division to take this divided by the factor, and then I would see what I have left over and continue factoring from there. One of these for you to try, so go ahead and try this question. When you're done, press play to see how you did. Again, what I'm looking for here is x minus 6 is equal to 0, so x is 6. That's the number I'm going to use. I'm going to take f of 6 and plug it in. And again, just keep your calculator handy. 2 times 6 to the 4th minus 13 times 6 to the 3rd plus 10 times 6 squared minus 25 times 6 plus 6. So 2 times 6 to the 4th is 2592. I'm just going to use my calculator as we go here. 13 times 6 to the 3rd gives me 2808. 10 times 6 squared is 360. 25 times 6, whoops, that's a minus, 150. And then plus 6. And now I'm going to take 2592 minus 2808 plus 360 minus 150 plus 6. And I do end up with 0. So keep in mind you're not always going to get 0, but because it's 0, I have determined that x minus 6 is a factor. The 0 is 6, but the factor is x minus 6.